Now we are going to see elongation of bar of varying cross sections. Let us take an example of bar of 3 sections having different lengths and areas. Here this is length of first section, L2 is length of second section, and L3 is length of third section. When bar is loaded with tensile force, what will happen? It will get elongate. There is change in length or increase in length. So after the application of load, length of first section is L1 dash, of second section L2 dash, and length of third section is L3 dash. Here there will be change in length of each section. Delta L1 is change in length of section 1, that is L1 dash minus L1. Delta 2 is change in length of second section. Here delta L2 is equal to L2 dash minus L1 dash, and delta L3 is elongation of section 3, that is delta L3 is equal to L3 dash minus L3. So total elongation of the bar will be delta L1 plus delta L2 plus delta L3. As the section of the bar are connected in series, total elongation will be equal to elongation of sum of the elongation of each section. As we know that delta L1 is equal to P1 L1 upon A1 E1, delta L2 is equal to P2 L2 upon A2 E2, and delta L3 is equal to P3 L3 upon A3 E3. That is elongation of each section. First condition, when all these sections are made up of different materials, then each section is having different modulus of elasticity. So delta L is equal to delta L1 plus delta L2 plus delta L3 is equal to P1 L1 upon E1 A1 E1 plus P2 L2 upon A2 E2 plus P3 L3 upon A3 E3. As here P is same, we can take it out of the bracket. So final equation will be, second condition, when section of bar made up of same material, that is elastic modulus of each section is same. So we can take it out P and E out of the bracket. So final equation is this. Next condition, Now, stresses in composite section. Consider a slab is mounted or fitted on column. This is slab and these are the columns. And this is ground. Composite section means these sections are arranged in parallel, whereas in bar of varying cross sections, the cross sections are arranged in series. Here, weight of the slab acting on the column what will happen? There will be a deflection of column. So note, in composite sections, elongation or contraction means change in length. Delta L is same for each section as they are connected parallel. So delta L1 is equal to delta L2, and load shared by each section here by column is different, depends upon area and modulus of elasticity. Here P is equal to P1 plus P2. Here load shared by column 1 is P1 and load shared by column 2 is P2. We can compare bar of varying cross section with composite sections. As I already told that bar of varying cross sections means they are connected in a series, and composite sections they are connected in parallel. So in bar of varying cross section, delta L is equal to summation of delta L of each section, whereas in composite section delta L, that is change in length of each section, is equal. In bar of varying cross section, force acting on each section is the same, that is P1 is equal to P2 is equal to P3, and in composite sections total load is summation of load shared by each section. Now we are going to see principle of superposition. In these, first of all, we must understand about equilibrium of forces. Consider a body and 10 kilonewton force is applied on the both side of the body. What will happen? Body will get elongate. Okay, take another example. This is body and 10 kilonewton force is applied on the left side of the body and 6 kilonewton force is applied on the right side of the body. What will happen? Body will move in the direction of maximum force, that is 10 kilonewton force. So there must be equilibrium, that is condition is that summation of forces along the x direction must be 0, or summation of forces along the y direction must be 0 for equilibrium of forces. So now we are going to see principle of superposition. First of all, what is the meaning of superposition? When a single bar is loaded with different amount of forces at different sections, then this is called as superposition. Here is the same condition, that is summation of forces along the x direction must be 0, or forces acting along the right direction must be equal to the left direction. Here summation of forces along the x direction is -10 plus 14 plus 6 is equal to 0. Here important is sign convention. Forces acting towards the left must be considered as a negative, and forces acting towards the right direction are considered as positive forces. This condition is only for principle of superposition. Now this is a bar loaded with different forces at different sections. If we consider this is section 1, this section must be in equilibrium. That's why we consider left forces equal to right forces. So here 10 kilonewton force acting on the both side of the body, both side of the section. Then section 3, here same condition, forces acting on the left and right must be equal, or summation of f of x is 0. Here 6 kilonewton force is acting on the both side of the section. Then second section, that is section middle section, here is the same condition, that is summation of forces acting along the left side must be equal to the right side. That's why summation of left side forces is 10 plus 10, that is 20 acting towards the left. Similarly, summation of forces acting towards the right side are plus 14 plus 6 is equal to plus 20, that is 20 is acting toward the left. It is very simple to calculate. First of all, we must find out the forces acting into each section. Then we are going to find out elongation of each section. As we know, delta L, that is elongation, is directly proportional to the amount of applied force. Higher is the force, higher will be the elongation. So delta L1, delta L2 and delta L3 are the elongations or change in length of each section. Delta L1 is directly proportional to F1, that is force in section 1. Delta L2 directly proportional to F2, force in second section, and delta L3 directly proportional to F3, that is force in third section. Different elongation of each section due to different amount of force or load. Consider the body. What will happen due to loads? It will get elongate, or due to compressive force it may get contract. Here we see that left sided forces and right sided forces are tensile in nature, that's why there is elongation. So L1 is the length of section 1, L2 is the length of second section, and L3 is length of third section. When after the elongation lengths are going to change, that's why L1 dash is the length of the first section, L2 dash is the length of second section, and L3 dash is length of third section after the application of force. Delta L1 is L1 dash minus L1, delta L2 is L2 dash minus L2, and delta L3 is L3 dash minus 3. So total elongation of the bar will be equal to summation of elongation of each section, that is delta L1 plus delta L2 plus delta L3. We know that delta L is equal to PL upon AE, that's why we can put delta L of each section into this formula. We will get this formula. So this is the final equation. First condition, when all these sections are made up of same material, means elastic modulus of each section is same. So we can take it out of the bracket and the equation becomes like this. Then second condition, if all the sections having same cross sectional area, simply we can take it out area out of the bracket. So final equation will becomes like this. Third condition, if all the sections having same area and same material, then here area and elastic modulus of each section are the same, so we can take 1 upon AE to the out of the bracket. Another condition, if all the sections having same length and area but different elastic modulus, that is different material, then length and area of the each section is the same, then equation of delta L will become like this.